Okay, so with this question, you've got to simplify the following expression, leaving your answer with positive indices. You can notice that it's a divide. With any dividing of fractions, what we always make sure we do is we use the keep, change, flip. So keep, change, flip, remember, is where you keep the first fraction the same as what it is. You change, the divide becomes a times, and you flip or invert the second fraction. So with this one, I'm just going to keep the first fraction the same as what it was. I'm going to change that divide to a times, and I'm simply going to invert, flip the second equation, or sorry, the second fraction. Righto, so it's the first step. Now, after that, we can do some cancelling. So if you look at the coefficients only at the front here, you can cancel top on bottom or crossways, diagonally. You can't cancel, across on the same level. So 6 and 18 have a common factor of 6. 6 goes into 6 once. 6 goes into 18 3 times. 4 and 10 have a common factor of 2. So 2 goes into 4 twice, 2 goes into 10 5 times. So at the moment I've just simplified the coefficients, and that is as simple as we can get those coefficients, so I'm going to leave that as is. From here there's a few things you can do, but what I like to do is I like to do the top first. So if we don't even if we just leave the bottom part out for now, only looking at the top section, we've got a coefficient of 2 times 1, which is 2. Then let's look at our x variable. We've got x to the power of 3 times by x to the power of negative 4. Well, if we had that as a normal index laws problem, remember when you're timesing, you add the indexes together. 3 plus negative 4 is negative 1, so it's x to the power of negative 1. So on top we've got x to the power of negative 1. And then with our y variables, we've got y times by y to the negative 3. That's y to the power of 1 there, and so that will be y to the power of negative 2 on the top. So the top part's done. So now let's only consider the bottom part. The bottom part, let's multiply these coefficients. 3 times 5 is 15. And then we've got x to the power of 1 times by x to the power of negative 2 on the bottom, which will give us x to the power of negative 1 on the bottom. And for our y variables on the bottom, we've got y to the power of 5 times by y to the power of positive 6, which is y to the power of 11 on the bottom. Okay, so if we get to that stage, we've got a fair bit of progress done there. The last thing for us to do is to simplify that as much as we can, remembering this positive indices. Now if we just have a look here, we've got y to the power of negative 1 and x to the power of negative 1 and x to the power of negative 1. They cancel out. If you've got any number, like 7 over 7 is 1. You've got 153 over 153, it's 1. So if you've got x over x, it's 1, and x to the power of negative 1 over x to the power of negative 1, that's also 1. So that whole thing cancels. Then if we look at the y variables, well, we've got a negative power there. To make a negative power a positive, you simply put it down on the bottom and change the power to be positive instead. So I'm going to leave the 2 up the top there. It stays up there. The x is gone. That y is going down to the bottom, and it's going to be y to the power of positive 2 there. So that'll end up giving 15 on the bottom. Then we're going to have y to the power of 13, because that's a times in there. That's your final answer.